take a look at example 5.53. So it says, in order to stay dry, you tie a cord to a pail of water and you swing the pail in a vertical circle of radius 0.6 meters. What minimum speed must you give the pail at the highest point of the circle so no water will spill out? Okay, so we're talking about this water inside this pail. So we have gravity trying to pull the water out of the pail. Okay? And gravity will win unless we have it moving in a circle. And so when it moves in the circle, the faster it goes, the bigger the normal force is. So this is one of those problems where it's like the minimum speed to go around a loop-de-loop, the minimum speed, because guess what? The water and the bucket, they're going to fall together. It's not like the bucket's going to continue on this circle and the water's going to fall out. They are kind of going to move together. So I could even look at this as what's the minimum speed so the tension is zero. But we are talking about the water. So we're going to talk about this normal force. So the minimum speed occurs when the normal force equals zero. This is the key bit of information I need to bring to this problem to solve it. Okay, so the water is going in a circle, so I need to identify the direction of AC, make it positive. Okay. We're going to go ahead and generate our equation. So we're summing up the forces parallel to the radius, setting it equal to MAC. So I have mg plus the normal force equals MAC, and we are going to make a substitution of v squared over r, because they do ask for the minimum speed, not the minimum angular speed or anything like that. We are going to choose normal force 0. When we make that choice, this becomes v min. Another fun fact here, mg equals mv min squared over r, as the mass cancels out. So it doesn't matter if you filled the bucket a lot or a little, it crosses out. The only thing that does matter here is the radius. If this bucket is very large relative to that cord you attached it to, it could be an issue. Solving for v min, and the minimum speed here is the square root of GR, as it's known. They do give me those values. So v min is going to be the square root of 9.8 times my 0.6. That 0.6 is kind of a pail in a vertical circle with a radius of 0.6. We're just going to assume that's the radius of the water, maybe the top of the water that we're looking at. Okay, v min comes out to be 2.43 meters per second. There we go.